1.1.1 Expressions. One easy way to get started at programming is to examine some typical interactions with an interpreter for the scheme dialect of Lisp. Imagine you are sitting at a computer terminal. You type an expression and the interpreter responds by displaying the results of its evaluating that expression. One kind of primitive expression you might type is a number. More precisely, the expression that you type consists of the numerals that are representing the number in base 10. If you present Lisp with a number 486, the interpreter will respond by printing 486. Expressions representing numbers may be combined with an expression representing a primitive procedure, such as add or multiply, to form a compound expression that represents the application of the procedure to those numbers. For example, add 137 to 349 evaluates to 486. Subtract 1,000, and 334, so 334 minus 1,000 minus 334 evaluates to 666. Next, you multiply 5 and 99, and we get 495, and we divide 10, so 10 divided by 5 evaluates to 2. And adding 2.7 and 10 evaluates to 12.7. Expressions such as these, formed by delimiting a list of expressions within parentheses in order to denote procedure application, are called combinations. The leftmost element in the list is called the operator, and the other elements are called operands. The value of a combination is obtained by applying the procedure specified by the operator to the arguments that are the values of the operands. The convention of placing the operator to the left of the operands is known as prefix notation, and it may be somewhat confusing at first because it departs significantly from the customary mathematical convention. Prefix notation has several advantages, however. One of them is that it can accommodate procedures that may take an arbitrary number of arguments, as in the following examples. So we can add 21, 35, 12, and 7, and we get 75. And we can multiply 25, 4, and 12, and we get 1,200. No ambiguity can arise because the operator is always the leftmost element and the entire combination is delimited by the parentheses. A second advantage of prefix notation is that it extends in a straightforward way to allow combinations to be nested, that is, to have combinations whose elements themselves are combinations. So, we can do add 2 elements, and the first element is itself multiply 3 and 5. And the second element is minus 10 and 6. So it evaluates 10 and 6 to be 10 minus 6, which is 4, and 3 and 5, which ends up being 15. Then it adds those two together, so we should get 19. And we do. There is no limit in principle to the depth of such nesting and to the overall complexity of the expressions that the Lisp interpreter can evaluate. It is we humans who get confused by still relatively simple expressions such as add, I have to draw this one out. So I'm going to copy this. Okay, so for me to figure this one out, it is quite intense. I can see why it's annoying. So, here we go. So, we're going to add here, and add we have this one. We have two things it adds. Cool. Then, in this box, we have multiply 3 and something. And then in this box, we add something and something. And then in this box, we multiply 2 and 4. This box, we add 3 and 5. Okay, so this one, so all of that is one thing we add. The next thing then is we add something and 6, and that something is we minus 10 and 7. Okay, so let's do this now. Alright, 7 minus 10 is going to be, or 10 minus 7 is going to be 3. Alright, then down here 4, 2 times 4 is going to be 8. And 3 and 5 is going to be 8. It's hard to see, sorry guys. Okay, 8 and 8 is going to end up being 16. 16 times 3 is going to be that, but let's do this one over here because it's easier. So it's going to be 9. And then we do 16 times 3, which is equal to 48. Pick a different color. 48. And 48 and 9 is going to end up being 57. So we're going to end up getting 57 out of that. So that should all equal 57. Okay, so that was intense and very difficult to figure out. So it says, let's make sure we got it right. Oh, sorry. Let's go back to copy this again. Let's put it in here. And see if it evaluated something. Oh. So anyway, which the interpreter would readily evaluate to be 57, which we got! Only after a lot of work though. We can help ourselves by writing such an expression in the form. So we add it times 3, and then it ends up being this next thing, which is kind of almost what we did. And then plus 2 times 4, so those two will go together, and then plus 3 times 5. Plus 3 and 5. So by indenting. Following a formatting convention known as pretty printing, in which long combination is written so the operands are aligned vertically. The resulting indentations display clearly the structure of the expression. Even with the complex expressions, the interpreter always operates the same basic cycle. It reads an expression from the terminal, evaluates the expression, and prints the result. This mode of operation is often expressed by saying that the interpreter runs in a read, eval, print loop. Observe in particular that it is not necessary to explicitly instruct the interpreter to print the value of the expression.